Hi students, welcome back to my YouTube channel SADHIK Physics. So we started wave optics. In the previous video we discussed Newton corpuscular theory and Huygens wave theory. So wave theory can explain interference and diffraction. Also we discussed interference, the concepts, no. So therefore the superposition of two coherent waves, no. So that interference of the two waves, so that is generally, therefore it can be applicable for sound waves and light waves also. So but here in this video, no, therefore we are going to discuss Young's double slit experiment, right. So we'll simply call it as YDSE, right. Young's double slit experiment. This is an experiment, so which will shows the interference in the light waves. Clear? So we discussed in the previous video, therefore the coherent waves can be produced by, therefore the splitting of a wavefront, no, like from single source, no, what we are doing, no, we are making the two waves that are said to be like a two coherent waves. Suppose two different light waves, no, therefore they are not coherent, no, so therefore they will not produce any interference pattern, no. So therefore interference experiment is done in the light, no, therefore that experiment is nothing but a Young's double slit experiment. This tells that light is in the form of like a wave, and from this experiment also we can calculate the whatever the wavelength of our light. Clear? Now let us see. So just we can just recollect it. So about the interference which I discussed in the previous concept, no. Interference is nothing but a, so for interference, so just overview, so 5-10 minutes, no. So superposition of the two coherent waves, no, therefore coherent waves means what? A constant phase difference, no, phase difference should be constant. Clear? So therefore two waves, therefore y is equals to, so y1 is equals to a1 into sine of omega t, and y2 is equals to a2 into sine of omega t plus phi. Therefore this is here, so phase difference now. Therefore phase difference does not depend upon the any time, so constant, and frequencies are also same. Therefore these two waves are said to be coherent waves now. Clear? Now so we will right, so if these two superimpose, no, so therefore we got it as like a amplitude, therefore amplitude can be written as root of a1 square plus a2 square plus 2a1 a2 into cos phi. Clear? Intensity we can rewrite it as I1 plus I2 plus 2 root of I1 I2 cos phi. Clear? This is intensity relation, no. So constructive interference also we discussed, no, constructive interference. So when phase difference it will be equal to 2n pi, so 2n pi, and path difference we got it as like a, so therefore n lambda, right. N starts from, so 0, 1, 2, 3. Constructive interference means bright fringes. Clear? So now therefore here destructive interference, no. So phase difference we got it as 2n minus 1 into pi, phase difference, no. Path difference we got it as 2n minus 1 into lambda by 2. So where n starts from 1, 2, 3, so on. Clear? Clear? So phase difference and path difference, no. So therefore this already we discussed. Therefore these are the two important things, no, we require, we are going to use in this video, we are going to use thoroughly about this one now. Clear? Right? So what is YDSE experiment now? Let us see. Here Young's double slit experiment, no. Therefore here YDSE. So Young's what he did, no, therefore he took it as like a one bulb here, no. So this is mostly like a yellow color light, no, therefore sodium lamp, no. So through this small hole, so the light is allowed to pass through it. So this light is coming here, no, therefore this to be compulsory like a monochromatic, no, therefore here, so therefore here, therefore this light is coming and falling on a one slit on cardboard sheet, no, so which is having two slits onto this. So what are the two slits now? Here this is one slit here, no, therefore here there is a one slit, and here also Thomas Young, no, therefore how we explain, I mean Huygens, So Huygens, how he is explained onto this one, no? So we can see it, no? See, this is one spherical wavefront is coming, and this spherical wavefront is come and fall onto this one, no? So you know that Huygens, no, what he said, no? He said that each and every point on the wavefront will act like a secondary source, no? This secondary source will give us like a one more light, no? So one more wave, therefore this one wave, so is coming out onto this one, no, through this wavelet, and through this wavelet, no, therefore through this one slit, therefore here the one wave is coming out. So these waves, these two waves, no, what will happen now? These two waves are said to be like a coherent wave. Why? Because these two waves are coming from where? Single source, no, and these two waves are going to get superimposed, no, and therefore if you superimpose, how they are superimposed, no? So I'll draw just roughly here so that you can understand very clearly. So now, so if you take it as like a compass, no, then you can understand very clearly. Just I'll draw it here, no. This is like some crust, no, therefore this is one crust. So suppose this is one trough, no. So right, so now this is one crust, no, therefore here, right, and this is one trough, no, right. So again therefore one more crust here, no. So if you draw with a one scale, so one compass, no, therefore you will get it as properly. See here, therefore at this point, no, therefore crust and crust, trough and trough, so crust and trough and trough, and crust. Therefore this one will forms like a, so crust and crust, trough and trough. In last class, last video, no, I already discussed interference, no, when crust is falling on the crust, no, therefore it will create like a constructive interference, no. Then next followed by this one, no, you try to observe here, no. So here there is a crust and trough, therefore here crust and trough, no. So this will gives us like a destructive interference, and here crust and trough, no, crust and trough, so not properly, therefore you can get it as this is your destructive interference. Again crust and crust, trough and trough, no, like that it will form, no. So this is destructive interference, dark bands. So this will create like a dark band, and this is like a bright band, no, it is going to create it now. So if this is allowed to fall on the screen, no, if it is if this superposition of these waves, no, if it is falls on the screen, no, therefore at the center point, no, so therefore here bright bands are created, no. Then followed by again some gap, no, therefore again one more bright band is formed here, no. So bright band means what? Bright spot, no, you can able to see it, no. This is also one bright band, it will be formed, or bright fringes. In this point, no, in middle of this one, no, there is a one dark fringe is created, no. This side it will be the dark fringe is created, no. Again this side the dark fringe, no. So again this side a dark fringe, no, is created, no. So again you will see that bright and dark, no, bright and dark, this fringe pattern on the screen. This is the screen, no. Clear? So this pattern you will observe, therefore the light rays which is coming and superimpose and falling on this one, right? So this experiment only we can call it as like a Young's double slit experiment. Clear? So this is an interference pattern, no? This can be explained only by assuming in the form light is in the form of a like a wave. So this is one experiment which strongly suggests that light is in the form of a like a wave. Here what is happening now? Light is interacting with the light, no? Therefore wave nature is getting dominated. Clear? So therefore now we will calculate it, no? Therefore all these things, no? So we will mathematically we'll calculate the positions of our bright band and dark band, no? And we will see the bright fringe, the size of the bright fringe, no? Therefore all this one, no, we are going to calculate it, no? How this bright fringe depends upon this distance and this wavelength and all this one, no? We will calculate one by one. So this calculation, no, so very very important, no. Suppose here there is a one slit is there, no. This is one right. So therefore here be careful, no. Therefore here now there is a two slits are there. So two slits are there. So these two slits are separated by small distance, no. Therefore here it is d. So the light is falling, no. Therefore the wavelength of the light is lambda. So this calculation, no, so very very important, no. Suppose Here there is a one slit. So therefore there is a screen is there which is at a distance is D, capital D. Clear? So therefore in the center point, no, where definitely there is a bright fringe will be formed, then followed by the dark fringes now. Now we will take it as a certain general point, no, general point I will take it, no, therefore some point is at the Y from the central bright fringe, from the, this is, you can call it as like a n is equals to 0. So therefore at this point, therefore we want to calculate, no, the wave is coming, therefore the wave is coming here, no, and falling at this point, and the wave is coming and, no, coming and falling on this point. Right, the wave is coming and falling on this one. So these two waves, no, go and superimpose, no, and it is going to form here, no. Clear? So this superposition, no, therefore how it will be takes place now, see here. Now, so here this point, no, you try to observe it, this point, no. So here now, therefore here this is one wave which is traveling, no, from here to here like this. So now see here like this one, no, therefore this is one extra distance, this is extra distance, no, from here to here both of they are traveling in the same distance now. Suppose here the crust is there, here also crust is created, no, definitely here crust and crust, no, trough and trough, crust and crust, trough and trough, no, same distance they are traveling, compulsory the bright fringe it is going to create it now. So if this crust is there, here there is a trough is created, no, therefore here the trough is created. So therefore here there will be a destructive interference will be takes place, or dark band will be takes place now. Here to form this crust and trough, no, therefore it depends on what now, it depends upon this distance, right. So therefore here to form this bright band or dark band, therefore that will be decided by this part, right. So suppose now let us see. So here this distance you can call it as like a path difference, no. Suppose this distance is forming one single wave, one complete wave, therefore then it will be forms like one crust, no. So this distance is nothing but if it's lambda, then crust and crust is created, therefore constructive interference is created, bright fringe will be formed. Suppose here one wave or two waves or 2 lambda, 3 lambda, anything, no, therefore if it is formed like this, no, definitely this one, no. This is nothing but what, this is nothing but a, so condition for path difference, condition for constructive interference, you can see it now. What is the path difference now? Here I told you n lambda, so delta path difference is equals to lambda, 2 lambda, 3 lambda, 4 lambda, then it will create like a constructive interference now. Now suppose at this point, no, now so suppose at this point, no, therefore here suppose at this point, so here there is a one half wave is created, no, half wave, then it will be the compulsory the here crust is there, here trough is there, here crust is there, trough is there, no, therefore that will be a destructive interference. This half distance, no, that is nothing but a lambda by 2, or one full and half, no, therefore 3 lambda by 2, so therefore 5 lambda by 2, this will create like a destructive interference. Clear? So therefore this is decides, this distance is deciding, therefore it should form like a constructive interference or destructive interference. Clear? So that's why we have to calculate the path difference, no, so for this one. Clear? So I think you got the clarity. So for this one, no, so suppose if it is fully like therefore lambda, 2 lambda, 3 lambda, so on, so constructive interference, no, lambda by 2, 2 lambda by this one, it is there, no, destructive interferences are created, no. Clear? So now we want to calculate this extra distance, no, therefore how to calculate this extra distance, no, let us see them. Therefore here there is a, so this is one screen, no, here there is a 2 slits are created, no, therefore here this is a 2 slits. Clear? So this distance is like, let us assume that it is D, and this distance is nothing but a, right. So this is your capital D. Now we will calculate some point, no, therefore at this point, clear? So this point we want to calculate, this distance is y, right, from the central bright fringe. Clear? So we want to calculate, suppose this is your S1 and it is S2. So this is nothing but a P. So therefore you can rewrite it as path difference. No, path difference is nothing but a, therefore S2P minus S1P. Clear? S2P minus S1P. This is your path difference now we want to calculate. So here we can use the trigonometry so that you can calculate very easily. So therefore suppose this is an angle theta here, no. So this theta, so therefore I can rewrite it as, this is your path difference, no. So theta, so I can write down opposite side, this is a perpendicularity. So this is your hypotenuse, no. So sin theta, it will be equal to delta by therefore d. So path difference I got it as, path difference I got it as therefore d sin theta. Clear? So this formula slightly it will be useful for us, no. You will see. Okay. So path difference is nothing but a delta d, no. Therefore here now, so here thetas are very small, no. Now this I got it, no, but I want this relation also. So therefore I will take this is your general point, no. This also angle theta. So I can rewrite it as therefore tan theta. So tan theta is nothing but a y by d. So therefore thetas are smaller. When thetas are small, so therefore sin theta is equal to tan theta, therefore equal to theta. Clear? So then both of they are equal, no. Therefore what I can write it now? So delta by d is equals to y by d. So this y distance now can be written as d by d into delta. So this is your distance, no, this distance, no. So depends upon this delta. Clear? So y is a position of your which fringe it is there, no, we have to decide it, no, that depends upon our path difference, no. Clear? So this distance, no, therefore I think you got the clarity onto this. So you can do it very easily. Now the positions of this one, no. So now we can write down positions of bright bands or bright fringes, no. So general formula is what you got it now. Therefore y is equals to, so y is equals to capital D by small d into delta. So bright fringes means delta, you know it now, therefore n lambda, therefore y n is equals to, so therefore delta is equals to, you know it, therefore delta is equals to n lambda, path difference, no. So therefore here n into d lambda by d. So n starts from 0, therefore y0 is 0. Therefore, so we are starting from the central central bright fringe now. N is equals to 1, first bright fringe, no. So y is equals to d lambda by d. So second bright fringe, no. Therefore, so y2 is equals to d lambda by d. Therefore, that is 2. Isn't it? So this is not only upward, also downward is also same, no. Therefore, you can take it as plus or minus, it will be there. So therefore, you can take it as plus or minus, below also it will be there, above also is there. Clear? Now therefore these are the positions of our bright fringes, no. This is your positions of our nth bright fringe, position distance from the central bright fringe, right. So now we will go for positions of dark bands, dark fringes. Clear? What is the position of our dark fringes, no? So we know it, no. Therefore y is equals to d by d into lambda. Therefore yn is equals to, lambda is, delta is nothing but a 2n minus 1. So 2n minus 1 into lambda by 2. Therefore d lambda by 2d. Clear? These are the positions of our right. I will write it as m. So that m, no. So this is your mth dark bands, positions of your mth dark bands. Clear? So therefore n is equals to 0 will not be there, no. Why? Because at the central, no, therefore there is no again dark fringe will not be formed, no. So that's why we should not start from 0, therefore here you have to start from 1 now. That's why I did not say that 2m plus 1. So if you see that previous video, you can understand that one, no. So which is very clearly, right. So here I will write it as 2m minus 1. So therefore n is equals to 1, therefore first dark band only will be there, no, substitute it now, therefore y1, so d lambda by 2d. So second m is equals to 2, therefore y2, so substitute it now, therefore 3d lambda by 2d. So m is equals to 3, so y3 is equals to 5d lambda by 2d, so on. So these are the positions of our dark fringes now, these are the positions of our bright fringes. I think you got the clarity onto this one, no? So therefore, so in this one of these two formulas are very, very important. Clear? Now we will see one more important now, therefore what you can understand here. So we want to calculate the what will be the size of the fringe, therefore that is called fringe width. So we will so fringe width, right? What is the fringe width now? So therefore here suppose if there is a dark fringe is there, no, therefore suppose this is your central one, no, so this is your therefore I mean first bright band, no, that's central bright band. So this is your first bright band, no, so this distance only you can call it as like a dark band. So this distance you can write down, therefore y this is 0. So this distance is nothing but our fringe width is denoted as like a beta. So this distance, this length of this one is nothing but a beta. How to calculate it now? The distance between the two consecutive fringes now. Therefore, so beta is nothing but a, so y1 minus y0. So y1 is how much now? D lambda by d minus 0. So therefore here fringe width we can rewrite it as therefore d lambda by d. So if you subtract this one same, subtract this one same, subtract this one same, subtract this one same, no, you can understand that all fringes are in equal in size. Therefore all fringes are equal in size. Understood, no? Therefore all fringes are in same size. Therefore fringe width will be constant. Therefore all fringes are in the same size now. How this fringe width is there now? Therefore it is depends upon the directly proportional to d. So we can see it now. Therefore I got the fringe width now. Therefore here d lambda by d. So therefore it depends on what factors now? Depends on directly proportional to d. That means if this is the slits now, therefore here this is a screen. So if this distance is increased, fringe width will be increases. Clear? That means if the screen is going far away, so these sizes are becoming bigger and bigger. So therefore if they are coming closer, so therefore if they are coming closer, so then fringe width will be decreased or becoming smaller and smaller. And it is beta is inversely proportional to the d. So therefore here these two are coming near to each other. Therefore these are becoming larger now, and these are becoming go far. If this is larger now, this will become smaller now. Therefore fringe width sizes will be smaller when they are far away. When they are closer now, therefore fringe width size will becomes larger. Clear? And beta is directly proportional to the wavelength now. You know that wavelength of the red color is greater than wavelength of the blue color. Clear? So therefore here fringe width for red color will be greater than fringe width for our blue color. Clear? So fringe width for red color so will be larger than fringe width for blue color compared to the blue color now, right? So here also we can rewrite it as one more important no. Suppose everything it is totally, if this is constructed in the air no, so beta in the air, so therefore what you can write it now, d lambda in air by so d. So suppose this totally immersed inside the one water no, therefore if it is inside the water, so therefore if the experiment is done in water, so beta in water, so we can write down there is no change in the d and d, d into lambda in water divided by d. Clear? So therefore what I can write it now, right? So you know that refractive index no, refractive index is nothing but a wavelength in air by wavelength in the medium. Therefore I can write down so beta in water by, okay, directly proportional no, therefore I can write it as here beta in air by beta in water, so can be written as directly proportional. D and D same, no? If you divide it, no, D by D cancel, no? Therefore, wavelength in air by wavelength in water, so this is nothing but a refractive index, no? So therefore, if it is this, if I take it, no, this, so therefore beta in water, so can be written as, this is in water, so beta in air divided by n. Clear? Understand, no? Therefore, in this way, therefore you can calculate this one. Clear? Some more applications, no, we will see. And as I said, no, therefore all fringes are in equal in size, no. Therefore, suppose here they may ask you what will be the distance between this fringe and that fringe, no, like that they will ask, no. So they can ask, no, therefore distance between nth bright band to mth bright band. So how to calculate it now, this distance, no? Therefore this is suppose I am taking, this is n is greater, so it will be ym. Therefore I can write down n minus m into d lambda by d. So we can write down n into d lambda by d minus m into d lambda by d. Clear? So this is your distance between both bright fringes, no, and also dark fringes also you can write down. Suppose if they are asking, so distance between mth or nth bright band to mth dark band. So y is equals to, therefore yn 1 minus ym. So ym is nothing but n into d lambda by d minus, therefore 2m minus 1 into d lambda by 2d. Clear? So I can rewrite it as d lambda by d. So therefore m minus 2m, so by 2 minus of minus plus 1 by 2. So these two get cancelled out, no, sorry, this is m, this is n. So therefore what I can write it now, that is nothing but a d lambda by d, therefore n minus m plus half. So actually don't remember this, all these formulas, no. So but so just right, just you can understand the concept, no, therefore you can able to do the questions. Don't remember any formulas. Clear? Now one more concept, no. Suppose here we said that beta, it will be the same d lambda by d. Suppose I am taking one screen, no, this is one screen. What I am doing now, see, therefore I am considering one small amount of area, this is the area I am considering now, right. So therefore in this area n number of fringes are formed, n number of fringes including bright and dark, no. So n number of fringes are formed, so by using with the wavelength of lambda 1. Now I am not changing any d and d, so therefore d and d are same. So we are not changing, and we are doing the experiment with lambda 2, so it is forming in the same area, therefore same area, m number of fringes are formed now. Therefore in this one now, this distance or this area, it will be the same. So therefore here what you can write it now, this total length of this one, no, therefore I can write down n into, therefore all fringes are in same size, no, therefore n into, therefore here d into lambda 1 by d. So it will be equal to same area, same distance, everything, no, therefore m into d lambda 2 by d. So these two are get cancelled out, no. You can have the relation n into lambda 1 is equals to m into lambda 2. Clear? This is also one of the important application, no. So for this, no. Clear? Next, one more important, no. Therefore they may ask you angular fringe width, very important, most of the students know. Angular means they will fear, no, right? Angular fringe width. What is angular fringe width, no? Angular fringe width means, let us see here, no. Suppose this is one screen is there, no. This is one screen. So therefore here there is a one fringe width is there, this is beta, clear. So it is making an angle theta here, no, this theta, so we can call it as like a angular fringe width now. Therefore, so how you can rewrite it as now, therefore this is d. So I can write down tan theta is equals to beta by d, clear. So therefore thetas are smaller, no, therefore fringes are very smaller in size, theta is small, no. So theta is equals to beta by d. If I write it now, beta, so beta is equals to d lambda by d, no, therefore I can write down d cancel, no, therefore so lambda by d, so will be your answer, clear. So this is nothing but a angular fringe width, it should be measured in terms of like a radians, clear. So also some experiments will be done, no, therefore they will tell that with one wavelength we are using, no, at certain position, no. So fifth some position at one position, fifth dark fringe is created, no, with another one wavelength we are using. So therefore which fringe will be formed at that point, no, like that questions also will be asked in the examination, no. So that also will see all the different type of model questions, no, we will see it now, clear. So this is first basic things, no, regarding the YDSE experiments, no. So thoroughly practice, no. Now we will see again. So one more fringes are there, no, therefore here all fringes are in same size, therefore all fringes are in same size. So you can draw the intensity variation, no, therefore here this is your intensity variation, no. Right. So these all are positions, no, we can call it as like a, so bright bands, because intensity is maximum here, no, bright bands, intensity is I max, clear. So these are the positions, no, so we will call it as like a, so intensity is minimum, therefore these are nothing but a dark bands, dark bands, dark bands, dark bands. So here intensity is minimum, clear, and all intensity variation it will be the same. So therefore intensities are, it will be the same. And one more important, no, then therefore here intensity is maximum, here intensity is becoming 0, therefore here energy at this point, no, is becoming to the 0, here energy is becoming like a maximum. Energy is maximum now. So is there any violation of our law of conservation of energy? No, there is no violation, no, but energy distribution is taken place, no. That means here whatever the missing energy is there, no, this missing energy was added at this point, no, and at this points, no. Therefore, so where energy is missing at intensity is minimum at that point, no, so that energy is given to the maximum duration, maximum duration, no. So this YDSE or interference is there, no, YDSE, that is nothing but interference is there, no, interference. So this is, there is no violation of law of conservation of energy. So this is nothing but a energy distribution, energy is distributed, right. So no violation of conservation of energy, clear. So in this way, so this also you should take in one point now. And sometimes one questions can be asked, no, listen carefully, no. Suppose here there is a, this is one slit is there, so these are 2 slits are there. So suppose now we can ask one question, no, if 2 slits are in same size, 2 slits are in same size, so what you can write it now, that means amplitudes are same, that is wavefronts are same, no. Therefore what will happen now, these dark bands which are there, no, it is completely dark, completely dark, right. So bright bands are there, no, therefore it is more brighter, it is bright, right, completely dark. Sometimes they will ask one question, no, suppose if the size of the slit is increased, if one of the slit size is increased, so what you are going to see it? That means If one slit, therefore this slit size is increased, what happens now? So when that means what will happen now? This is A1 and A2. Therefore here A1 means it is nothing but intensity, we can write it as now. Therefore here, so here I1 and I2. So I1 will be larger than I2. Therefore that is nothing but what? Through this one now large amount of light is coming, through this one now less amount of light is coming, no. So therefore that is nothing but A1 will be greater than A2. It indicates that, so A minima will be nothing but A1 minus A2. That means, so still certain amount of intensity will be there, no. Therefore dark band will not be completely dark. Clear? So therefore completely dark, so therefore bright band, so therefore intensity of the bright band, no, will increase. So these type of questions, no, frequently asked in the examination, no. So if one of the slit size is increased, no, so therefore what will happen now? Dark band will not be completely dark, no, and intensity of the bright band, no, therefore, because through this one, no, more light is coming, no, therefore bright band will be increased very large. Clear? So therefore, so these are the basics, no. Therefore we will see one question regarding the YDSE, then we will go for some more different questions, no. So one simple generalized question, no, we will discuss here, no, so that you get one complete idea about this one, no. So one question, so let us see. In YDSE we are using wavelength of about 500 amps, 5000 angstrom. So where D is nothing but 1 millimeter, capital D is nothing but 1 meter. So what we are doing, no, therefore we are using distance between the two slits, no, is 1 millimeter, and distance between the slits and the screen is 1 meter, no. Therefore we can calculate so many things, no, anything you can calculate. You can also comment it, no, therefore whatever the thing you want to calculate it, no. So just here we will calculate. First one, let us calculate what will be the fringe width, no. Fringe width we will calculate it, no, right. So one fringe width, so therefore what you can write it now? D lambda by D. So what is D? 1, therefore 5000 angstroms, 5000 into 10 to the power of minus 10 by 10 to the power of minus 3. So therefore here what I can write it now? Therefore 5 into 10 to the power of minus 4, therefore so 0.5 millimeter will be the size of this one. Clear? Second one now, second question. If it is immersed inside the water, you know what is the refractive index of the water? 4/3. So what will be the fringe width in water? So therefore it will be nothing but a fringe width in in air by it is n. So air is nothing but a 0.5 divided by 4 into 3. So therefore you can write it as, so 1.5 by 4. So millimeter will be the fringe width. Now, what will happen now when it is immersed inside the water? Therefore fringe width, so here this is larger, no, larger than 1. So therefore fringe width in a medium, in a denser medium, right. So what you can write it now here? Fringe width in a denser medium. So this is divided by larger number, no, therefore more than 1. So definitely it will be less than this one, no, therefore less than, so it is in air. So in rarer medium only fringe width will be larger, in denser medium fringe width will be smaller. They may ask you one more question, no, therefore what will be the angular fringe width? Angular fringe width, what you can write it now? So therefore here beta by, therefore D, or lambda by D also you can write now. Beta by D, beta is how much now? So 5 into 10 to the power of minus 4 divided by 1. So 5 into 10 to the power of minus 4 radians. This is your angular fringe width. Clear? So they may ask you distance between the, okay. So one more question, no, we can write it as, so position of fifth bright band from the central maximum, right. So therefore here from central bright band, so he is asking, no, therefore what will be this one, no, y5. So therefore here it is nothing but a 5 into d lambda by d. So 5 into beta. So what you can write it now? 5 into 0.5 mm, 2.5 mm will be your distance of the fifth bright band. So therefore here we can write down in now therefore distance between, we can write down distance between, so second bright band to therefore here sixth dark band, right. So distance between the therefore here what you can write down, distance between this one, no, y6 minus y2, clear. So y6 is nothing but a, so 2n minus 1, 2 into 6 minus 1 into d lambda by 2d minus, so 2 into d lambda by d. So here what I can write it now, therefore here this is 12, 11, therefore 11 by 2, so minus 2 into d lambda by d. So this is nothing but a 4. So 4 what I can write it now, 4 means 7 by 2 into beta. 7 by 2 is nothing but a 3.5 into 0.5 mm. Clear, na? Right. So 0.5 it is nothing but a 1 by 2. So therefore 1.7. 1.7, therefore it is mm. Similarly, so you can simplify it, no, you can get your answer. Clear, right. Again they may ask you one more question, no, therefore here one more question can be asked, no, therefore here in the distance, in the position of O, therefore right, like a right. So in the distance of O, this is about how much now? In a distance of O, 5 millimeter, find the number of fringes including central one now. Including central one now, right. So number of fringes including central one now. Therefore you can see it now. Therefore here I did actually this one now. Therefore you can see. So this is your position of your fifth bright band now. How much it will be now? 2.5 mm. That means, so here from here to here. So therefore here 2.5 mm and here 2.5 mm. Clear? So therefore what you can write it now? So this it is create like a fifth bright band now. Therefore this is nothing but a fifth one now. How many number of bright fringes, bright bands include of this one now? So how many fringes will be there now? Therefore here this side it will be the 5, this side it will be the 5. Number of fringes are it will be, number of bright fringes it will be nothing but a 10. Clear? Huh? So therefore here, clear? This is 10 plus 1, therefore it is 11. Therefore, so these are the number of fringes, no? Therefore you can calculate it now. Like so, like so many ways, no, you can expect the question. So based on this region. Clear? Right. I think the video is more got lengthy. So we'll take it as like a two parts of this one. No? Therefore, YDSE experiment theory. So we will end it here. No? Then in the next video, so we will discuss the numericals. No? So which are involved for in the YDSE. Even the slits are placed and different, if it is white color is incident onto the slit, no, therefore how it is going to perform, what is going to see the screen, on the screen, no, which type of fringes will be seeing, no, and the Okay, therefore one glass plate is placed in one of the slit or two slits, no, what will be the position, thickness, all this one no, we will discuss in the next video, no, right. So thank you, please subscribe to my channel, no. So if you are first, so if you therefore if you like this my video, no, therefore please share so that others also can learn the physics very easily. Thank you.